Okay, here I just wanted to mention note 1 in that, this is something that comes up in quite a few materials, and so for instance, like in my PhD dissertation, when I was looking at various or a type of numerical solution for various forms. This was a form that I did not actually deal with because I just dealt with linear things. But yeah, so in this case, it says, some materials change their thermal conductivity as their temperature changes. Okay, and that is that K is actually some K of U. Okay, so now what happens is they say, well, just the pure homogeneous heat equation now would become 1. It looks like a U to me. So U sub T is equal to 1, there's the 1, over the C rho. Remember that alpha squared was K over C rho. But see, now K is not a constant. It's a function of the temperature. And so they have the partial of K of U times U sub X with respect to X. So they mentioned that. Now, so what would happen then is you would have, right, if you're going to do this, you get a product rule, because there's a function of U, there's a function of U. So you get a product rule and a chain rule because it's K as a function of U. So you would get, something like what, if you wrote all this out, you get the derivative of the first. Well, the derivative of first would be K, well, actually, right, that is K sub U, right, of U, and then times U sub X times U sub X, and then plus K of U times U sub X, X. So you see, this is very nonlinear. Oh, that starts looking mighty ugly to try to solve that baby. But nonetheless, yeah, if you have materials that act like that will change their conductivity with the temperature. So like, I believe superconductors do that. So, that's what happens with superconductors, I think, is they get hotter, they get more conductive or something, or maybe it's colder. I don't know. I'm not a physicist, so I don't remember, but they can get much more conductive by changing their temperature one way or the other. Not sure which it is. So that's just a little bit on note 1, and I just want to point that out. The notes 2, 3, and 4 are kind of self-explanatory. 3 in particular, notice the units are all there. You're going to need that for or 2 of the problems. You need to look back at note 3 for the units. Alrighty then. I think that's good for note 1.